Xin and welcome to this special video on differential equations. We are going through one of my favourite differential equations questions. Are you ready for this? Are you ready? Yes, you are. Let's go. Here's the question. An inverted conical funnel is full of salt. The salt is allowed to leave by a small hole in the vertex. It leaves at a constant rate of 6 cubic centimetres per second. Given that the angle of the cone between the slanting edge and the vertical is 30 degrees, show that the volume of the salt is 1/9 pi h cubed, where h is the height of the salt at time t seconds. Show that the rate of change of the height of the salt in the funnel is inversely proportional to h squared. Write down differential equation relating h and t. Oh, isn't that great? Now, why is that one of my favourite questions? Well, frankly, it's about calculus, of course, differential equations, and it's also about interpreting the question. Really, it's about interpreting the question. Why the hat? Why the hat? Well, at the beginning it says an inverted conical funnel. Well, what is an inverted conical funnel? Well, this is the best cone that I have. Okay, so this is a cone, only we normally picture a cone this way up. An inverted cone might look something like this. To me, it's still a cone. It is still a cone. However, you might think of it as an upside down cone. Of course, there's no such thing as an upside down cone. It's either a cone or it isn't, in my opinion. But when they say an inverted conical shape, basically they're meaning that. So when you draw a diagram of it, let's just put this back on again. When you draw a diagram of it, it wants you to draw it like this. Okay, so here we go. Make it nice and wide. There we go. And if you want, looking head on, that's what a cone looks like. I've not drawn it in 3D though. I hope you don't mind. But that's our cone. Happy with that? Great. Now, what else does it say? It says it's full of salt. Ooh. Anyway, moving on. The salt is allowed to leave by a small hole in the vertex. Okay, a small hole in the vertex. So basically that's the only vertex on the cone, isn't it? The rest, you've got a surface which is curved, of course, and you've got a flat top here. Okay, but it's allowed to leave, which kind of makes sense. So if you were to have a hole at the bottom there, then salt is allowed to leave. After all, that's what a funnel's job is, getting rid of, in this case, salt. Sometimes water or fluid, but in this case, salt. Well, reading on, what else does it say? It says it leaves by a small hole at a constant rate of 6 cubic centimetres per second. 6 cubic centimetres per second. So what is our derivative expression going to be? Well, the cubic centimetres is a measurement of volume, and of course salt is measured in volume. This whole shape is measured in volume as well, and it's leaving over time, so that means we've got dV dt is equal to, and because it's leaving, it's decreasing, -6. Okay, -6. So that's that bit of the information. Okay, happy with that? Good. Let's have a look to see what else it says. Given that the angle of the cone between the slanting edge and the vertical is 30 degrees, I better put it on, okay? So this here is a slanting edge, you see, and this here is the vertical. It's saying that that angle there is 30 degrees. Obviously in my Vietnamese hat, it is actually a bit bigger than that, okay? Hope you like it, by the way. Obviously I picked it up at the Hard Rock Cafe. Yes, they have one of those as well. In Saigon or Ho Chi Minh City, depending which one you prefer. I think Ho Chi Minh City is the preferred, but they still call it Saigon. So what they're saying is that that angle there is 30 degrees, okay? Now, when you've got a cone, how do you normally label this up? You normally label a radius, so that bit there is a radius, and you normally label a height, okay? That bit there is a height, okay? A bit wobbly, this hat. Yeah, that's why you've got this thing here. You're supposed to have that on, okay? But I don't tend to sort of wear it like that. Anyway, yeah, so that's that bit of the information. Show that the volume is, okay, let's write this down. I'm going to show that the volume is 1/9 pi h cubed. 1/9 pi h cubed. Okay, now we know what the volume formula is. It's 1/3 pi r squared h, isn't it? Okay, so let's begin with that. Volume is 1/3 pi r squared h. We want to get from there to there, basically. Whoa! How do Vietnamese maths teachers put up with these? Maybe they just take them off. But if they're teaching outside, how do they put up with it? See, like I'm turning and whoa. Anyway, let's keep on going. Okay. Right. The thing is, this has got an equation in terms of r and h. This here's got an equation just in terms of h. We've got to try and eliminate r somehow, and we've got to use this to do it. They gave us that angle there for a reason. We've got to be able to use it. So we've got to get an expression in terms of R and H. Now notice the way I've drawn it as a right angle triangle using trigonometry. We can set up a relationship involving the 30-degree angle R and H. And we use tan because we're given the opposite and the adjacent. So tan 30 degrees is equal to R over H. And then from that we can write down what R is. R has got to be H tan 30 degrees. Okay, what is tan 30 degrees? It's quite cold if you're in Vietnam. Sorry, poor joke, I know. But anyway, 1 over root 3. Yeah, so you get R equals H over root 3. So what that means is, so I need a bit more space. Here we go. Board rubber. So you've got 1/3 pi and then that squared. So H over root 3 squared H, which of course is 1/3 pi. That would be H squared over 3, another H, and then 1/3 times a third is a ninth. 1 over 9, then pi H squared times H is H cubed. So 1/9 pi H cubed. Phew, that's that part of the question done. Okay, I'm getting a bit fed up with this because it just keeps on wobbling around. But anyway, you ready for part 2? Of course you're ready for part 2. Let's go, let's have a look. Okay, part 2 of the question coming up. This thing here is a bit kind of awkward, isn't it? I thought it might be just to wear it like that, but then I thought if I do, can you see, I'm kind of, it's not very comfortable, and yeah, yeah. So, and this strap here doesn't really hold it in place, so it's like, what is the use of this strap? Anyway, I was pleased with my gift, so I didn't really complain at the time, but on a practical point of view, this red strap doesn't really do much anyway, okay? Anyway, part 2 of the question, what was it again? It was a show that the rate of change of the height of the salt in the funnel is inversely proportional to H squared. So what are we after there? Show that the rate of change of the height of the salt. Rate of change of the height of the salt is dH dt, isn't it? Okay, and show that it's inversely proportional to H squared. So what we're after is some sort of relationship that looks like that. Okay, dH dt equals K over H squared, because then it's inversely proportional. Okay, our answer should be negative, of course, because it's actually decreasing, but we'll just see what happens as we're going through it. And then write down a differential equation relating to H and T. Well, that's kind of it, isn't it? So I don't see the point of that last question, if I'm perfectly honest. Right, let's have a look to see what we're going to do then. So I've just cleaned my board a little bit. This is what we had. We had V equals 1/9 pi H cubed, and we had all of this, of course. We had dV dt equals -6 from the beginning of the question. I'm hoping the negative will feature in here. Right, we need to get an expression for dH dt, don't we? So using the chain rule, what can we get? So dH dt is equal to, obviously we have to use that, so dV dt, and then we have to multiply that by, we need a dH on the top there, and we want the dV's to cancel, and then lovely, we have dH dt, okay? I wonder what the Vietnamese is for lovely jubbly. I'm sure I knew at the time, but I've kind of forgotten. Okay, so Xin Chao is the only one that I kind of remember. Okay, hello, by the way, in case you didn't get it. So let's see. So dV dt is -6. dH dV, well, we don't have that, but we can get dV dH, can't we, by differentiating that. So if we differentiate that, let's write that down by here, shall we? We can get dV dH is going to be, so 3 times the 9th is 1/3. And then pi H squared. Okay, ready for this? Right, hang on to your hats. Put it in here. So -6, and then dH dV is the reciprocal of that. So reciprocal of 1/3 is 3, so multiply by 3, and then you've got over pi H squared. And that simplifies to -18 over pi H squared, which is it. And I was hoping it'd be negative, wasn't I? So I could write it as is equal to, now how do I want to do this? What's the wording of the question say? It says show that the change of height is inversely proportional. It doesn't need to have a negative. It's not saying that show that the decrease, okay, is in there. It's not showing that it's a negative rate of change. So you can either write it as negative k or as positive k. I'm going to write it as positive k, h squared, where, let's just emphasise this, that k is equal to negative 18 over pi. And then that's enough. I've got dh to t equals k over h squared. Hence it's inversely proportional. And at the same time, of course, I've got my relationship for dh to t. I've got my differential equation dh to t. And that is it. That is it. I hope you enjoyed that question. Okay, I really hope you enjoyed that question. Yeah? Right, until next time, I'll see you again.